Welcome to the bones, everyone. I'm going to go over just some basic information, kind of introduce you to the skeletal system. And of course, for the physiology part of the exam, you always want to know what the function of something is. So we're going to go over just a little bit of each of these. And some of this is going to be really familiar because of the information I gave you about organ systems. So we look at support. That's a basic thought of what bones do. They provide a framework. And I think the word framework is a really important word to pick out, because if you think about building a house, you put down all of the wooden frame supports, the 2x4s, and then you put everything else on it. So the bones, of course, are going to provide the framework for the body, for everything else. So again, it is a foundation. That's another good word, foundation. Protection is usually what comes to mind. People think of the skull and how it protects your brain. That's an easy, obvious function of bones. They protect things. So if you look at the spinal column here, what are we protecting there? Well, that's the spinal cord. And again, that's the cluster of all the nerves that are going from your brain to all the parts of the body. So the spinal cord, very important part of the body. And so we have these very specialized bones in the spinal column that protect them. Now, I've already talked, when I talked about the internal organs and the position, you think three-dimensionally, these ribs are going all the way around the body, and they protect more organs than most people think. Again, we have the heart and the lungs, but all of these internal organs, the liver, the kidneys, the adrenal glands, all of these are still fairly high up. So the ribs are giving you a lot of protection. So that's a very important function of bones, will be to protect. Now, in conjunction with muscles, the bones provide a way to move. So this is sort of, the book has actually added a new term now, anchorage. So I'm adding this in, anchorage / locomotion. So the bones are providing this material to hook the muscles to allow them to move. So together, we have to have muscles and bones to be able to move. So I thought this was a nice picture here. You get the idea. So again, one of the basic functions of bones will be to provide an anchor for those muscles. Mineral storage. Now, I think in our country we are brainwashed to drink milk to get calcium to build strong bones, and that's very true. We need calcium to create bone. But on the other hand, we also use the bones to store that calcium. We need calcium for other things. So calcium is very important for muscle contraction. It is used in nerve conduction and in blood clotting. So if you don't get enough calcium in your diet, you will take it from your bones, which unfortunately can lead to brittle bones that break very easily. So again, it's very important to get enough calcium in your diet for many reasons, not just for strong bones. So the function of bones is actually to store that calcium and phosphate for other uses in the body. Hematopoiesis. This is a very fancy word here. Easier term to remember would be blood cell formation. So all kinds of blood cells are formed in what most people have heard of. They've heard of bone marrow, but inside most of the long bones, in most of the bones of all children, of course children are actively growing. They need more blood cells. But as we age, we don't have as much a need for that. But most of the bones will still contain some bone marrow, and we are forming red blood cells. Red blood cells, of course, carry oxygen. There we go, oxygen there. And again, red blood cells don't last forever. They last about 3 months. So we are continually replacing these used red blood cells by the body. And white blood cells are very important. They're used to fight infection. So all of this is one of the functions of bones. Lipid fat storage. We store fat everywhere. In Unit 2, we talked about the hypodermis, how we store fat there. We store fat all around internal organs, and yes, even in the bones. So as we age, that red marrow that's producing blood cells actually gets replaced with adipose, and you actually store fat inside the medullary cavities of these larger bones. And here's a picture of the real thing. Adipose is truly yellow. So inside of these large bones, I think these are cow bones, you'll see the actual yellow fat. Now, back to important topics like how are you going to answer questions? Well, hopefully by now you realize that I'm always going to ask you about basic functions. And so sometimes students just go in and they start memorizing things and they say, okay, bone functions, we got protection, which is obvious. And we've got something like fats, and that's all they remember, okay? They just remember that one protection of bone is protection. I'm sorry, one function of bone is protection. Now, the problem with that is, you know, I could say something like protection from outer space, aliens. You know, there's so many things that you're protecting from. So I need a little bit more. I need a statement. Bones protect internal organs from damage. Or you could say bones protect, such as an example would be the skull protects your brain. I need just a little bit more if this is going to be an answer from you. So if you want to mention something about fat, you're going to say storage of lipids or fats, not just fats. And so again, as you're learning things, be aware that I want you to know more about this than just memorizing protection, storage, anchorage, that sort of thing. I would expect a little bit more on the exam. Now, just a few more things I wanted to bring up while we're introducing bones. And again, most of the horror movies, you see things walking around, and this would never happen. The bones would fall apart. You got to have something to hold bone to bone. So I think I brought this up briefly when we talked about connective tissue, but ligaments are a specialized type of structure that literally holds bone together. And you can think of them almost like really tough ropes that will hold bone to bone. And then again, we also need to know that the muscles have to be attached to the bone somehow, and that's a tendon. So we'll be picking up lots more about tendons when we talk about muscles. So back to our tissues. Again, I'm expecting you to still remember some of this. So which kind of tissue is a ligament? Well, it's connective tissue. Okay, connects things, which is pretty easy. So all types of connective tissue have those basic three substances, and this is going to help you when we talk about bones as well. So the protein fiber, it needs to be collagen. Collagen is the strongest, so I need something that's like a really thick rope that's going to hook bone to bone. So what I'm going to have to do is pack that collagen fibers in very, very tightly to create literally a rope that can hook bone to bone. Now, if you look at the actual histology, the cells, you're going to see there's not that many cells in a ligament, okay? But they're going to be, here's the living cell right here. This is the cell. And then tons and tons of these collagen fibers that are all going the same direction. Because again, this is a rope that connects things. So I would want those collagen fibers to be in line with each other, all densely packed. Now, unfortunately, sometimes we tear or damage a ligament, and it's called a sprain. And unfortunately, it's difficult for that to heal. There's not a large blood supply with something like this. It's harder. Now, they have sometimes surgeries required, so it could be actually more painful than breaking a bone because it would take longer to heal. And again, we're going to find out that bone is very vascular, a lot of blood supply there. So it actually easier to heal a broken bone than a stretched or torn ligament. And again, I think one of the reasons bones are so interesting is because we can see the remains from hundreds and hundreds of years ago and find out all kinds of things about people. And the reason for that is what bones are made of. They're a very unique substance. They are living and non-living at the same time. It's a very strange substance that we have to be able to produce it, yet it has to be very, very hard. So most of bone is actually non-living or inorganic. So 65% is this mineralized product that everyone thinks about, and that's the part that remains. Everything else basically degenerates over time and disappears. Okay? But this part will remain after we die. So what type of tissue is bone? Again, just like ligaments, it was connective tissue. Okay? And again, all types of connective tissue have these basic parts. You have to have live cells. We're going to have a whole video about bone cells that will talk about that. We have a very little ground substance in bone. Remember, if you have more ground substance, it's more watery. So don't see very much of this at all in bone. But we're going to see lots of protein fibers for strength. And just like in ligaments, we're going to see collagen. Okay? Collagen is our strongest protein fiber. So by necessity, we're going to put a lot of collagen in bone and make it a lot stronger. So that leaves the rest of bone. If 65% is inorganic, mineralized, then 35% has to be this organic component of bone, which is typically, you want to think of it as live or coming from something that is alive. So this organic part will be the live cells. We have live bone cells that have to be there. Okay, and by definition, anything organic means that it has come from something that was alive. So the cells produce these collagen fibers. So therefore, the collagen fibers, the cells themselves, all of that is organic or produced by something that is alive. And this allows the bone to be actually a little bit better. If it was very, very strong, completely strong, without anything alive in it, it would be extremely brittle. And if you've ever dropped something on a tile floor and it shatters, you don't want your bones to be like that. You don't want to be that easy to break. So this actually provides a little bit of resistance to this force, this ability to withstand fractures. So you don't want them to be too brittle. So welcome to the bones, everyone, and I hope you enjoy this unit. Going to be a lot of interesting topics, and if you can watch all the videos about bone cells, would be a very good idea. Thank you.